Welcome back to the show. This week, I want to start with a paradox that sounds like a joke, but is honestly the defining feature of the AI industry right now. Imagine spending billions of dollars building the most advanced autonomous artificial intelligence in human history. A digital brain capable of passing the bar exam, writing flawless software, and summarizing decades of scientific research in seconds. Truly mind-blowing capability. Then when it comes time to actually sell this marvel of engineering to Fortune 500 companies, you realize you have to hire thousands of human beings to physically drive to your clients' offices just to plug it in. That is the exact paradox defining the tech industry this week. The illusion of a frictionless, magical AI revolution is crashing headfirst into the messy reality of enterprise deployment. And that collision is what we're unpacking today. I've spent the week going through a massive stack of system cards, earnings whispers, and press releases stretching up to July 1st, 2026, and a very specific narrative emerges from the data. The era where companies competed solely by building larger raw intelligence models is over. We've crossed a threshold. The new battlefield is defined by three things: regulatory friction, the deployment of highly capable human engineers, and a race to put incredibly cheap autonomous agents right in your pocket. Let's get into it. The first story is happening at the very top of the technological food chain, the frontier models themselves. And if you're wondering why you personally don't have access to the absolute smartest AI systems right now, this is why. US regulators moved this week to impose new access controls on the most advanced models, similar to the earlier restriction on Anthropic's newest models, Fable 5 and Mythos 5, from foreign nationals. OpenAI was forced to severely limit the rollout of its brand new GPT 5.6 family, the Sol, Terra, and Luna models, releasing them only to a small group of trusted enterprise partners approved in advance. The problem with these restrictions is fundamentally mechanical. The mandate sounds simple on paper. Don't let foreign nationals use the tool. In practice, how does a cloud provider verify the citizenship of a developer logging in from an IP address in Seattle in real time? They can't unless they start demanding passport uploads for every API call, which would destroy the user experience and violate a dozen privacy laws in the process. So Anthropic was effectively forced to pull the models entirely rather than architect a citizenship verification system that couldn't work anyway. Meanwhile, as you may recall, a separate regulatory branch designated Anthropic as a supply chain risk. This came after the company declined a request to allow Claude to be used in autonomous weapon systems without human oversight. And in an interesting countermove, one US state signed a deal to deploy Claude across state government operations at half price. Different arms of the regulatory landscape reached completely different conclusions about the same piece of software. One saw a potential security concern requiring export controls. Another saw an efficient administrative tool worth investing in. The strategy whiplash was extreme. On July 1st, just days after enforcing the restrictions, regulators suddenly dropped them entirely. Why? The reason is the most interesting part of this saga. While the restrictions were being enforced, two Asian AI startups, Fugu and Tulongfeng, went ahead and launched models with capabilities that directly rivaled Mythos. That forced a painful realization. Banning American models domestically doesn't stop the technology from existing globally. If the US restricts its own companies, it literally hands market dominance directly to foreign competitors. The math is brutal. Now, the safety concerns behind the original restrictions aren't unreasonable, and it's worth being honest about that. If you look at OpenAI's own system card for GPT 5.6, they rate their flagship model, Sol, as high risk in three categories: cybersecurity, biological, and chemical threats. That sounds alarming at first read, but you have to look at what high risk actually means in their testing framework. The system card details that Sol is exceptionally good at finding vulnerabilities in software code. It can locate the bugs, but when OpenAI tested it, the model was completely unable to autonomously chain those vulnerabilities together to carry out an end-to-end attack against hardened targets. It did not reach their critical risk threshold. Here's the practical distinction. Sol is a highly capable assistant for a human security researcher, offensive or defensive. It is not an autonomous cyber weapon operating on its own. OpenAI's counter-argument is that keeping these tools out of the hands of cyber defenders leaves systems more vulnerable, because right now Sol is better at identifying and patching vulnerabilities than it is at exploiting them. Here's what this means for you. Regulatory whiplash on frontier AI is now a business risk factor to price in. If your enterprise strategy depends on a single frontier model provider, you need a sovereignty audit. Who can flip the switch on the AI you depend on? And what's your fallback plan when they do? So if you're an AI company and your smartest, most expensive model just got tangled in regulatory red tape, what's your next move? You pivot. And that's exactly what happened this week. The industry is executing a massive shift away from building the absolute smartest model toward making mid-tier models insanely cheap, highly mobile, and completely autonomous. This is what people are calling the agentic shift. The goal is no longer to have one omniscient oracle sitting in a massive data center. The goal is to deploy models that can take independent action on the edge in your pocket. Anthropic's release of Claude Sonnet 5 is the prime example. They claim Sonnet 5 matches their older, heavy-duty model Opus 4.8 on almost every benchmark. That alone would be huge. But the real story is the price. They introduced it at just $2 per million input tokens. For anyone not living deep in developer documentation, a token is basically a chunk of a word. A million tokens is roughly equivalent to 750,000 words. That's about the length of the entire Harry Potter book series. Anthropic is letting developers feed an entire library of text into their AI for $2. Why does this price matter so much? Because of how these agents actually work. An agent isn't a simple question and answer bot. It operates in a continuous loop. It looks at a problem, makes a plan, tries an action, evaluates if it worked, and if it failed, it tries again. It's essentially talking to itself over and over to solve a problem. And every single time it thinks it consumes tokens. If tokens are expensive, an autonomous agent that takes 50 steps to book a flight and reconcile your calendar bankrupts your company. At $2 per million tokens, continuous autonomous reasoning finally becomes economically viable. That is the unlock. The token economics of your AI stack have crossed the threshold this week. Autonomous multi-step workflows that were financial suicide 6 months ago are now sustainable at scale, which explains why these agents are suddenly leaving the desktop. Look at your smartphone. The way you interact with it is about to fundamentally change. Cursor just launched a mobile app to guide coding agents on the go. An app called Acti is embedding an AI agent directly into your smartphone's keyboard. OpenClaw released an automation agent natively on iOS and Android. These represent a massive shift from continuous manual input to supervisory management. You aren't going to open 5 different apps to check your bank balance, transfer funds, and email your accountant. You're going to give a high-level directive to an agent on your phone, put the device back in your pocket, and let the software execute all the steps. There's even a hardware rumor worth flagging. And I want to be clear, this is a single-source Wall Street Journal report that requires verification. The journal claims SpaceX showed investors a prototype for a sleek handset-like AI device that integrates XAI directly into the hardware. Elon Musk publicly denied this, calling it utterly false. But the fact that Wall Street is actively hunting for this kind of hardware shows where the market believes we're heading. We've stopped trying to build one omniscient oracle in a massive data center. We're now mass-producing a million brilliant interns that live right on our phones. But having a million cheap, brilliant interns highlights the exact paradox we opened the show with. A cheap intern is great in theory. If you don't train them on your specific company systems, show them where the files are kept, and give them the right permissions, they are completely useless. Say you're running a mid-sized logistics company. You have this cheap agent on your phone. Why can't you just point it at your company's legacy inventory system and tell it to optimize your supply chain? What physically stops that from working? The messy reality of enterprise data stops it. Your logistics company probably has data split across a cloud database, 3 different proprietary software tools from 2014, and thousands of unstructured PDF invoices. An AI model doesn't natively know how to read any of that. You have to build custom data pipelines. You have to set up strict permission guardrails so the intern doesn't accidentally email everyone's salary to the entire company. You have to create a system to double-check the AI's work so it doesn't hallucinate a shipping route that doesn't exist, which perfectly sets up Anthropic's other major launch this week, Claude Science. And interestingly, this is not a new AI model, it's a workbench, a dedicated environment tailored specifically for researchers. It connects natively to over 60 existing scientific databases. It allows a scientist to use a main AI assistant as a project manager. That manager can then spin up specialized subassistants to process proteomics data or analyze genomics. And crucially, it includes a separate, dedicated fact-checker AI whose only job is to evaluate the outputs and ensure calculations and citations are accurate before anything is finalized. Think of it this way, it's like handing a brilliant chef a recipe, but the chef doesn't speak English and doesn't know your kitchen. If you don't build a kitchen tailored to them, translate all the labels on the spice rack, and hire a manager to shout orders, no food gets cooked. Building that kitchen is incredibly labor-intensive. which explains the billion-dollar announcements from all three major labs this week. Amazon announced they're funding a massive new internal organization of forward-deployed engineers, or FDEs. They're literally physically embedding human software engineers into their clients' offices to deploy the AI. OpenAI just launched a $4 billion joint venture to do the exact same thing. Anthropic followed with a $1.5 billion initiative. They're all copying the playbook pioneered by data analytics firms like Palantir. This is the realization of full-stack AI. Tech companies finally understand that selling a business an API key to a language model is just a recipe for churn. The business will try it, fail to build the kitchen, get frustrated, and cancel the subscription. To deliver actual return on investment, you need the whole package: the compute infrastructure, the base model, the orchestration layer that tells the agents how to interact with those messy legacy databases, the user interface, and human engineers physically embedded in your clients' offices to stitch it all together for their specific workflow. Here's what this means for you. If you're an operator or investor, the pure API business model for frontier AI is under pressure. The winners of the next phase are going to look more like consulting tech hybrids than pure software companies. And if you're evaluating vendors, the presence or absence of a forward-deployed engineering team should be at the top of your due diligence checklist. Underneath all of this software, there is a brutal war over who owns the hardware. The scale of capital being deployed is almost difficult to comprehend. Reports this week indicate Meta is planning to spin up an entirely new cloud infrastructure business, literally just to sell off their excess AI compute and models. They're following the exact same strategy SpaceX and xAI used when they leased out excess capacity at their Colossus One data center. Meta has committed to spending $182.9 billion on AI infrastructure, almost $200 billion. Data centers the size of small cities. Sit with that for a second. At a certain point, the internal applications of your AI, better ad targeting, chatbots inside Instagram, cannot generate enough revenue to justify a nearly $200 billion capital expenditure. You're forced to become a cloud provider. You have to sell the raw computing power to other companies just to balance the books. But the hardware monopoly companies like Meta rely on is starting to crack. Just this week, a startup called Etched, which competes directly with NVIDIA, hit a $5 billion valuation and booked $1 billion in contract orders. OpenAI announced its first custom chip, codenamed Jalapeno, built in partnership with Broadcom. The skeptical question here is fair. Are we looking at a massive hardware bubble? AI chips depreciate incredibly fast. A chip bought today might be obsolete in 3 years. To understand why companies are spending this money anyway, you have to understand the difference between training chips and inference chips. Training is the process of building the AI's brain. It requires feeding the model basically the entire internet, which takes massive network clusters of highly flexible chips running for months. That's what NVIDIA has historically dominated. Inference is what happens when you actually ask the AI a question. You aren't building the brain anymore, you're just using it. Inference doesn't require maximum flexibility, it requires extreme speed and efficiency. Think of it this way: training is studying for the bar exam for months. Inference is practicing law on a daily basis. As the industry shifts into deploying millions of agents, the bottleneck moves from training to inference. Startups like Etched are designing application-specific integrated circuits, ASICs, that are hardwired to do literally one thing: run language models. Because they aren't weighed down by general-purpose architecture, they can run inference much faster and cheaper. Which brings us to the only metric that actually matters anymore. It is not about which chip has the highest peak specifications. The defining metric of the next decade of AI is cost per watt. If you're running 10 million agents simultaneously, a 10% reduction in your energy bill could mean the difference between a profitable quarter and bankruptcy. NVIDIA obviously knows their monopoly is under threat. They released software updates this week that reduced token processing costs by 5 times on open source models like DeepSeek V4, just through software optimization. They're physically embedding themselves into the US supply chain, partnering to build infrastructure in 43 different states and manufacturing chips with TSMC in Arizona. They recognize the physical layer is the ultimate moat. They want to be the inescapable bedrock of the AI economy, from the power grid to the server rack. And the physical layer isn't even restricted to Earth anymore. Firefly Aerospace is currently running NVIDIA Jetson platforms in lunar orbit. When you have a satellite taking terabytes of high-resolution photos of the lunar surface, Beaming all that raw data back to Earth over limited radio bandwidth takes too long and consumes too much power. So instead of sending photos back for humans to look at, you put the AI chip on the satellite. The AI analyzes the raw data in orbit, identifies valuable anomalies, and only transmits the insights back to Earth. It solves the bandwidth bottleneck by putting intelligence at the absolute edge of the network. Here's what this means for you. If you're an investor, cost per watt is the metric to build your thesis around. The winners of the next decade won't necessarily have the smartest AI. They'll be the companies that own the physical data centers, secure the cheapest power contracts, and run inference at the absolute lowest cost. Let me leave you with a final thread to pull on. We started this briefing looking at regulators trying to control frontier AI with export bans and strict borders, whether it was Fable 5 restrictions, GPT 5.6 partner-only rollouts, or supply chain designations. The underlying assumption is that a country can control the flow of advanced AI by controlling the physical or corporate infrastructure that runs it. But here's the question worth genuinely sitting with. As these AI agents become cheap enough to run natively on our phones and capable enough to navigate the web autonomously, what happens when your digital agent starts negotiating, contracting, and transacting with another digital agent halfway across the world? They operate completely unbound by the borders, the tariffs, and the export controls that regulators are currently fighting so hard to enforce. When the intelligence is everywhere and costs practically nothing, the traditional levers of regulatory control might just stop working entirely. And suddenly, managing 1 million digital interns talking to each other looks a lot more complicated than anything anyone modeled in the lab. That is the strategic environment we are about to walk into. Watch how it lands. Position for it. And if you're an operator, the next 12 months are going to reward the companies that figure out cross-border agent governance before anyone else does. The ones who wait for a regulatory framework to catch up are going to spend a lot of money learning that framework doesn't exist yet. Thanks for going down this week with me. Pay attention to who's holding the keys. I'll see you on the next one.